you running your effect, your reverb? Are you putting it after the processor, or are you putting it in the daisy chain in the back connections on the processor, the break?
No, that was by you, boy. He's got submit.
Yeah, it's working. That's way too much, man.
Okay, you're doing it to a PC. Okay, very good. Are you using like Ableton Live or Pro Tools or which PC version are you using?
Yeah, that's probably good right there. It's just trying to see exactly where my carrier should be.
Hey, Truck, you gonna... Roger, sounds real good and real clean, real clear, real crisp. And even in a little pile-up condition there, you can hear the audio cutting through. It's nice.
Very good. Like I said, it's right on the edge. It sounds really good. It matches your... Yeah. It only says turn down the mic.
If it's directed injected Cobra 2 grand, you're already there because it's a DC coupled stage. Everything from the base of the small NPN transistor that feeds over to the larger transistor is all DC coupled. There's no bandwidth limitations there whatsoever, so the high frequencies are not limited, and the low frequencies are only limited by the size of the coupling capacitor that you use. So when you fed the audio into the base of the NPN transistor, when you fed that directly with the capacitor, what size cap did you use?
That's an awful lot of swing.
On four wheels in that Dominator pickup truck. Good day to you, Slim 001. Goddamn.
Oops. As a matter of fact, that was way too low.
Oh my God, that's plenty big. I mean, even a 4.7 is fine. So if you've got 22 microfarads in there, you're fine. So yeah, all your bandwidth limitation is in your audio equipment or the PC.
Hey, Duckhunter, Motormouth, Maul, got your radio there, buddy?
You don't got to boost the bass up anymore. You might find that you're all out of the bass, and you might need a little bit more drive, a little bit more peak-to-peak voltage feeding it. But yeah, bandwidth there's no limitations to what you're doing there, except for some of the audio levels that you have available. Is the PC maxed out, or do you have a lot of headroom left on it?
Do you have a watt meter? Can you give me a percentage? Is it like 10% of your max?
Yeah, Rhode Island's out here.
30 or what's percentage or wattage, or do you just go by the meter on the radio? Okay, this is my field strength meter. I'm going by that. Oh, a little too far. That should be about 30, swinging 30 out of the radio. Yeah, so that would be 3 coming out of the radio, so it'd be 30.
No, it sounds real good. It didn't make a big change, but it does sound good. I can play it back for you real fast and let you hear what it... Let me take the silent part out in the middle here and get rid of that so you don't have to listen to that again here.
Here on the mixer, hold on. All right, that should be a lot more bass.
Oops, hold on, let me do that again.
Here on the mixer, hold on. All right, that should be a lot more.
You can see the bandwidth. The bandwidth really didn't increase a whole lot, and your carrier part that doesn't have a bandwidth. Your carrier is right smack dab on frequency. Everything's perfect. All you're doing is you're modulating the envelope. You're changing the envelope with the carrier. And so yeah, all your audio that you want to do, all the processing, if it's direct injected, either that cap is too small, it might be like something ridiculous, or there's a limitation in the audio. But yeah, now it depends on where you're putting the audio too. Wait, hold on a second now. There's a C174, I think, on a Cobra 2000. And And C174 has an input side which comes off the TA7222 audio amp, and it's got an output side that goes to the base of the first NPN transistor and the two-stage AM voltage regulator, right? You're feeding your audio on the output of that cap, right? I think it was a 0.1 to start with, and you put your cap on the output side, feeding the base of the NPN. Because if you didn't, if you put it on the other side, then you still have the frequency limitation, which is what it sounds like. Because you should be able to put gobs of bass in there. It should get so muddy and bassy on my end, it should go real low. So verify that you got your 22 microfarad capacitor on the output side of C174. They're great.
And it's starting to detect a little background noise. I don't like background noise, but yeah, that thing is loud. A lot louder than it used to be. Sounds good, dude. So you experiment with it a little bit. Find out where the sweet spot is. You can usually tell. Oh, you don't have a watt meter in line? 588.
No, I don't, but I've got reference points to what it should be, dude. That should be real close to, like I said, that's probably just a little less than 100, swinging about 350.
That's how you should do it, but you really should use a non-polarized capacitor for audio. I don't know if you'll hear the difference in bandwidth, and you may not even hear a difference at all, but ultimately in the perfect world, you should be using a non-polarized capacitor there, even though the schematic shows it's got, I think the schematic may show they use a polarized cap. I think if you look, it's a non-polarized or a non-polarized mica cap. But anyway, yeah, you should use non-polarized. But I don't think that'll make a big difference. I think there's just a certain degree of a distortion that you may get. But your bass, your bandwidth, I'm not sure how much. You should be able to dump a lot more low frequency in there if you're feeding the base of the transistor.
Okay, that's about 50 right there. Hello?
Yeah, but that sounds like really staticky kind of, and just doesn't sound good right there.
Yeah, it sounds good right there, huh?
Yeah, it still doesn't sound good right there.
It don't sound good?
No, well, do it again. I don't know, just a second ago you kind of broke up for a second.
Oh, what a racket, no doubt.
Okay, that's a 100-watt dead key, going about 550. Hello, 1, 2, 3. Breaking up?
No, it's okay now. Well, that's about what I'm doing. About 100, doing about 30.
Roger, very good. Well, yeah, interesting. You got an oscilloscope by chance handy?
Fuck, man, kicking it back,
That's it. I'm just on the driver now.
Roger, yeah. Look at put the scope on wrap some wire around your coax and hook that to the BNC connector and plug it into your scope and look at your envelope growth. And you'll see the energy, if it's there or not. And then also look at the audio feeding the capacitor coming out of the computer or coming out of the transformer. Oh, a high-low C coil adapters, so unless it's a real wideband hi-fi one, they may be restricting you as well. They may have a natural roll-off. So look at the audio and the scope before the transformer, after the transformer, and then on the RF. And when you hear the distortion, you should see it distort on the scope. You'll see it when you hear it. You'll actually see it before you hear it. And then look at the different stages and see if the distortion is there at one stage or the other. And I'm going to guess that your transformer might be limiting you a little bit on the low frequencies.
Yep, under a light. Yeah, just make it out of aluminum. Yeah, I would. But I don't have a handbrake. I'm not going to hand perform it. Looks pretty good. I was looking just cardboard. Anyway, yeah, I'm just going to be kicking it here. I got to run out to trucks later and bring some paperwork out to him. Kick that with him for a minute, and that's about it.
also with a regular probe or just even a pair of alligator clips, and look at the audio coming out of the PC where it goes into the transformer, coming out of the transformer where it goes into the coupling cap, and then look at the RF envelope and see if they all look the same. And if you see a distortion somewhere, you'll know where it's coming from. But yeah, you should be able to bury that bass and hear ridiculous amounts of bottom end. On my receiver over here, which receives from DC up to 6 kilohertz, I should have been able to hear just big rumbly bass. And there was no bass in there when you added it in there. It just really didn't sound much different. Low 133.
Oh, that would have loaded in the back.
No, get back over Mr. Evil.
83, Missouri. Shot a whole lot of good in northeast corner. Thought about it. West 83, 122 on the rocky coast of Maine, trying to get into your receive.
Motormouth, Maul, 588. Sure, Mr. McGould.
Oh, it wasn't distorted. It got bass here, but it wasn't distorted here. Check the sound.
Okay, right there. See, I brought it up. See, it's just kind of turning into distortion, though. You hear it? It's like it don't want to pass it right there. Know what I mean? Hello. And I played around with the settings a lot, but it just turns into distortion after a while.
At the end, you took it out, but it's passing it just fine. But I think your EQ, when you boost 80 hertz, there's actually a bell curve.
Don't get back on that station.
Below it, so you got to re-EQ and create another curve within the curve. But it's passing it just fine. It's got plenty of response. The way you monitor it will have a lot to do with how you come up with the final result. Sometimes it's better to take a regular narrowband receiver and put it through an LPAD, like an 8-ohm LPAD, so you can turn the receiver up to about 11 o'clock, which would normally blow your eardrums out, and then turn the LPAD down so that the headphones are a good level, and then adjust your audio for the best you can there, clean, crisp, bassy, and everything good. And then when you listen to it on a wideband receiver, it should sound a lot better. If you maximize it for a wideband receiver, it'll sound muffled on a CB receiver. But no, it's passing the lows just fine. That distortion you're hearing, are you listening to that audio off of another radio, or were you listening to the audio when you hear the distortion? I like that one. Yeah, the one that you were before was a little bit tinny sounding. There was a weird...
Try this one here, see what this sounds like.
then you get the loaded one here.
If it ever loads up. If it ever loads up on me there, Roger.
I think the next thing you need to play with is really not so much more equalization, because as you if you start EQing a lot, what happens is you start increasing overshoots, and things get a little bit weird. So what you want to do now is mess around with some multi-band processing, something that'll take the bass and the mid-range and the highs and apply a different attack and release time to each one, and then balance them back together again. And so, yeah, that's really the next step. I think it sounds pretty good, if you ask me. I mean, it sounds great over here.
Badboy around the west side, just checking in. Superpower Badboy just drove on in.
Oh, nice guy. 5 transistors. 5 transistors.
Roger. What was the name of the software again? Wait for Coondog Gun Key. What was the name of that software again? Roger. LAM keys. Go ahead and tell me what the name of the software was again.
Yeah, I guess you guys are near each other. You can hear them backscatter. Let me,
What was that software called there? Once again,
pulled pork. Slow simmering. About 10 pounds of pulled pork in the other room, so I just kind of come back up in here in my radio.
Oh, FM studio, okay.
Oh, Superpower Badboy got down.
Roger, there's another one, I don't know if you tried it or not, called Stereo Tool. It has a bunch of stuff in it too, and it's free. Stereotool.com, you can go there and check it out.
Got it all, man. You got a big hammer out here, man. You got a lockdown. You got a lockdown outside Los Angeles, California, man. You out here in Hollywood. Hey, Coondog, you out here in Hollywood. Coondog, you Hollywood, man. Put it on you later, Badboy West Side. Have a good day.